first off, an apology because I wrote this PowerPoint based on the Esri lab. I had to kind of go back in today and strip out some slides, so I hope it's still kind of cohesive. Lidar stands for Light Detection and Ranging. You can see it written in a lot of different formats. I have not found what is the correct way to write this. I've seen it with a little I and a capital DAR. I've seen it as all caps. I've seen it called laser altimetry. Yeah, so I can't find, I went to the USGS, I went to Esri. Does not seem to be a consistent way to call this type of data. But so anyway, that's what we're working with. So, when we were collecting information with our GPS units, we were not using remote sensing. We were actively on the ground next to or close to the item that we were trying to get data collection from. And so LIDAR is a way that we collect data, but instead of a passive receiver, we have an active receiver. So when we look at remote sense data in the next couple weeks, we're going to look at images where the images were created by the reflection of the sun, and the cameras just collect that reflectance, right? So if I were to take the temperature from a satellite image, I'm not creating any temperature, I'm just collecting what's already there. LIDAR is different. LIDAR creates a signal. So this is called an active remote sensing sensor. And what it does is it shoots out a laser beam, many thousands, per second, and it collects the time that it takes that laser to be reflected back to the collection unit, right? So it actually sends out these pulses. It's like sonar. Sonar sends out a sound pulse and then counts how long it takes that sound pulse to come back to them or echo back. So this is one of the differences between active and passive. So one of the things that you use remote sensing for is to get really high resolution topographic maps. And what you should have noticed about the lab or the exam is that you had 30-meter topographic or 30-meter DEMs, which were really not appropriate for the task that I gave you, right? You were really zoomed in, so it gave you a very choppy, very pixelated image. And so on that first lab about about raster data, we talked about the size of that DEM and the accuracy. LIDAR gives you very, very accurate, very high resolution data. And so they use that to create more detailed slope, more detailed aspects. They also use it to create three-dimensional surfaces. So if you want to look at urban, U-R-B-A-N, urban studies or biomass studies, they'll use LIDAR data because it's very detailed. So here's a difference in this, even between a 10-meter DEM and a 1-meter DEM. You can see how pixelated this is. And if you're looking at the colluvial channel here or the alluvial channel, you really can't see much detail. But if you look at this 1-meter DEM, you can see that whole, this is just amazing what you can determine from the 1-meter DEMs. Okay. And so at U of O, when they do their environmental studies or their geomorphology, stream geomorphology, being able to use LIDAR can show the active channel and also show really clearly all of the former channels. So they can get a very detailed study of these oxbows and these channel scars and be able to map how channels have changed over time. So the older DEMs that you may find have about 6 to 12-inch resolution. The newer DEMs have 4 to 8-inch resolution. So again, if you think about that as the size of your grid or your square, you're getting a much more detailed product. So when the airplane or the satellite, typically we're looking at a lot of airplane LIDAR data taken from like small focus studies, but if you want kind of the whole higher level or state level, you would be doing higher altitude planes. But the Lidar instrument scans about 400,000 pulses of light per second. And each pulse of light hits something and reflects back what it hit. And so that time between the pulse, so when I send it and when it comes back, is that time delay that gives the elevation difference. So if I know how high my plane is above the ground and I know how long it takes that signal to hit the top of the building or the top of the tree or the bottom of the creek bed, then I know I can begin to build a point cloud of information about that topography. Yeah?
But don't different objects and colors reflect different light? So how does it determine?
We're not doing color. We're just doing, I'm sending a Lidar signal and it's bouncing back. This is the active piece, right? I've got control of what comes back. So I'm going to send a Lidar pulse back down to you. It's going to come back to me, okay? Now when we look at remote sensing and we're looking at that multiple channel, that's when you get different things reflecting back different wavelengths, okay? But that would be multiple spectrums. We're just looking at this one Lidar spectrum. So what we get from each of those 40,000 pulses of light per second is an x coordinate, a y coordinate, and the elevation or the z coordinate, okay? And all of that data together is called a point cloud. So if you think about a plane flying over the college, and I can't even do the math here, and they fly 5 flight lines and it takes them 20 minutes, if I do 400,000 signals for that 20 minutes times 60 seconds per minute, I've got a lot of data, huge amount of data. So Lidar files are big. They're in the gigabytes. Okay. So you get your start pulse, it hits, it gets your return pulse, blah, blah, blah. This was on the Esri. I thought it was cute. Okay, so what you get back is what they call a point cloud. And the point cloud represents the elevation of the landscape, right? So the height of crops, the height of forests, road beds, railroads, airports. You can get power lines. If it hits on a power line and returns, you'll get the height of that. It will give you the height of everything, right? And so let's see. They're doing where do I get to? Hold on, one more thing. Okay. But what it does is Lidar is able to understand first return from second return from third return because the feature may bounce or the feature may get ricocheted off something else or the light may. And so those different returns are able to be divided into bare earth or top of the canopy or top of buildings or somewhere in between. And so when we looked at Fugro last year, we had all of those points on the map and then we drew that transect and you could see that three-dimensional image of Fugro. And that's kind of what you're going to look at with ArcGIS this time. So when you download Lidar, you often will get it in one of two formats. You'll get a LAS file or you'll get an ASCII file. And ArcGIS is set up to work best with LAS files. And so if I have an option, I always take the LAS file. Some places give you the LAS file and the DEM and the slope. So you can download all the derivatives at the same time. And so that can be an advantage of what they call some of the Lidar vendors. Now, I'm telling you that I can get an idea of the bare earth. And so how does it do that if it hits a tree, right? How can I figure out what the bare earth is? Well, actually, it can't. But there are so many lasers being sent out that just by chance, enough of them get through the canopy, through the leaves, through the whatever, that I'm able to get enough of those ground hits. Also, they tend to fly Lidar scenes when you have leaf off. So you have a better option. Now, if you're going to do mountains with Doug fir, you're never going to get leaf off unless you've had a fire. So basically, it just kind of sees through those holes. Okay. So what you're going to do in this first lab is you're going to bring in a total file called a LAS file, and you're going to create a LAS data set. It's really important that you look at the metadata that comes with your file, because you need to know what the projection was, you need to know what the horizontal units are, and you need to know what the vertical units are. Are they measuring height in feet or meters? And all of that should be in your metadata. Because when you build your data sets, your LAS data sets, you have to input all of that information. It doesn't read it automatically. And so then once you bring in your LAS data file, you can start to visualize the data. You can look for places where there's holes in the data, where maybe it didn't collect enough data. You can look for places where there's too many data points, which may mean an overlap, where the plane flight overlapped itself. So that could be too much noise. And so one of the things that you would do for an employer is you would bring up the data, you would record the coordinates, you would take a look at the data and say, you know, we've got the northeast sector really well covered, but there's a big hole down, you know, in the southwest. So I don't know if you want to have them fly another flight. I don't know if there's somewhere else we can get some LiDAR data to fill that in. So if you have a project that you want to do and you download your LiDAR data, you really need to look at it first to make sure that it has enough of what you need, right? Because you may get some data where there was a lot of interference and the data points were not collected. They talk in the third lab, I think they mentioned brake lines. And so I had to do a little research on this, but basically a brake line helps because you get your points and LiDAR kind of interpolates the spaces in between. A brake line often helps when there's a really clear cut, like a bank or a cliff or something, and so sometimes you'll want to create brake lines, and I don't think we'll get into that too much. All right, but just so that you know what they are. So if I could zoom in on this a little bit. Let's see if I can zoom in. Bad. Okay, hold on. That might help. On the left are contours that were created from LiDAR. And one of the things you can see is that it's really choppy, not great lines. So sometimes LiDAR gives you too much information and too much noise. And so often you can take those LiDAR points and generalize them and smooth them out so that they make good contours. The contour map on the left you would never want to produce for anybody because it's just too kind of crazy. There was some actual disagreement on, let me see if I can move that back in here. So once you get your LiDAR points, one of the things that they did in the Esri tutorial is create what they call a multi-point file. In the new method, having a LAS data set, you don't have to do that. So if you're ever working for somebody and they're asking you, did you create a multi-point file, you've actually skipped that step using the LAS data set the LAS data file so that you don't have to do that. It makes it a little bit easier. Okay. The other thing the Esri data talked about was the difference between geodatabases when you're using LiDAR. Basically, a personal geodatabase is not suitable. So when you create your geodatabase, make sure that you create a file geodatabase and not a personal geodatabase. Yes, ma'am?
Where do SIDs fit to that?
That's it, the enterprise. Enterprise geodatabase would be the SID, and those are pretty much organizational geodatabases. The difference between an SID geodatabase is that Caitlin and I can be working on the same file at the same time. We can both check it out, which is good and bad, I think. You know, you could have some good stuff or some bad stuff. They're huge. They're running on big path servers. Most people working privately or in small organizations just would use a file geodatabase. They're set to be 256 1 terabyte, but they said they can extend to 256. That's a huge extension. I don't think I understand that, but that's what the other thing I read in Esri is they don't put Lidar files or DEMs in the geodatabase. You can, but they leave them in the folder. I don't know. They just said that was their recommendation when I went through that. Although the woman whose data I have, that's not where she put it. So I think that might have been an Esri thing, and I don't know if that's completely true. Definitely make sure you do a file geodatabase, and I recommend that for everything that you do anyway. Price uses personal geodatabase, and I do not know why, but the file geodatabase seems to be more robust. One of the things that I'm going to ask you to do, turn in as part of your products, is I want kind of a workflow document that can be used by you, but just I think would help you kind of go back to think, what is it that you're really doing and why are you doing it? That would be a generic self-tutorial, right? And so this was the one in the Esri example that talked about, the first thing they're doing is organizing their data. They're going to calculate statistics. The second thing they did was create a subset. Then they grouped the data. So I just want you to have some kind of flow chart, step by step, that just would help you kind of remember, what to check and what to step into. The last thing that I want to talk about is when you get your Lidar data, your last file, and you look at it in ArcGIS, there's a Lidar dataset toolbar. One of the things that you'll notice is that all of the files have a class code or a class definition. So if I want to look at just the bare earth, right, no vegetation, I'm going to choose class code 2. So that will take out all the points that are only on that bare earth file. The number 1 unclassified means everything else. So, and what that means is the first thing it hits, right? The first, the treetops, the roads, if that's what I'm seeing, the tops of cars, that's what you get. If you want to create a digital elevation model, you would use that class code 1. If you want to create a ground earth, you would use the class code 2. This is not consistent. So one of the things that you need is when you download Lidar data, you want to make sure that you can use the metadata to find out what these things stand for. Because different vendors may choose to number them. You can't always count that a number 1 is a non-ground and a number 2 is a bare earth. So, and once you get your Lidar data, then you can do all the things that we've done once you create your DEM. So I'll talk about how to create the DEM next week, but right now I just want you to start visualizing the Lidar